Okay, the series is constructed with some squares and using the diagonal. So we can see that A1 is 400 square cm. A2 is simply makes up of a quarter of it, but because to make up the square we need to times 2, and finally we get 200 square cm. A3 similarly, we just take a quarter of A2 and we multiply by 2, we get 100 square cm. So correspondingly, the area of the nth term is actually 400, you look at the pattern going on here, times half. That's because a quarter times 2 is half, to the power of n minus 1, whereby r is actually the common ratio we realize. You can see 200 out of 400 is equivalent to 100 out of 200, which is half. Common ratio is half, which is the value of k that we are looking for. Second part, okay, to show that ln A1 plus ln A2, okay, is equals to what is given. Alright, so let's write out the ln terms first. Ln of A1 plus ln of A2 all the way to ln of the area of the nth term. Okay, so simplifying it, okay, rearranging, we actually get ln A1 times A2 times A3 all the way into AN. Take note, this is a multiplication, not a addition. So using the laws of the logarithms, okay, I'll write out the A1 terms again correspondingly. So we see that it's actually 400 times half the power 0 times 400 times half the power 1 and so on. And until finally we reach 400 times half to the power of n minus 1. This is the what we have found out earlier in part 1 here. Okay, so simplifying it and grouping up the terms, we see that it's actually ln to 400 to the power of n, okay, because there are n terms, n minus 1 plus 1 is n, and half, okay, half, take note, half we need to take the power of 1 plus 2 plus 3 and so on until we reach n minus 1. Okay, so we realize that this is actually an arithmetic progression. The power is an arithmetic progression. So I do the arithmetic progression at the side here, which is actually 1 plus 2 plus the sum of the arithmetic progression, which is n minus 1 out of 2 times 2, a being the first term of 1, n minus 1 minus 1 times b, which is also 1. Okay, so simplifying this, we get n minus 1 plus n minus 1 times n minus 2 over 2, and the sum of this arithmetic progression is actually n times n minus 1 over 2. So putting this back into the power and opening up the brackets, we get ln 400 to the power of n plus ln half to the power of n and n minus 1 over 2, bringing the powers down using the laws of the logarithm. We get n ln 400 plus n to the power of n times n minus 1 over 2 times ln to the power, ln half. So correspondingly, the value of a is n, and the value of b is n times n minus 1 over 2. Thank you.